Now question number 7, we have a curve. A curve has equation y equals to 2 plus 3 sine half x for 0 to 4 pi. Find state the greatest and least value of y. As we know that the value of sine half x is always going to lie between -1 and 1. So least value of sine half x is -1 and highest is 1. So we can use this one to find out the least value. So least value of this function is going to be 2 plus 3 into sine half x is -1 for the least value. So 2 minus 3, this is going to be -1. So this is one answer. Another one, we will have the greatest value. So for the greatest value, we will take it 2, 3, and the greatest value of sine half x is 1. So 2 plus 3, it is 5. So greatest value is 5 and the least value is 1, right? Now sketch the graph of this curve. Now if you see here, let me write down the equation here. The graph is, we have here 2 y equals to 2 plus 3 sine of half x, right? Between 0 to 4 pi. So you can see, so now this is 2 plus something, so that means value of y. If you notice that the graph of the sine x is like this, okay, so this is 0, pi, and this is 2 pi, right? So this is the graph of sine x. So now this is moved up 2 units going to be upward. So greatest value we have 1, 2, 3, 4 and 5. So greatest value is 5 and the least value we have here -1, right? So the greatest value of sine is, this graph is going to, it will lie on here, the other one is going to be here, the -1, right? So this graph is now moved from 0 to 2 here. This, it should start from here, this point. Okay, now sine pi, if you take the value sine pi, if we have this, just you can use the calculator. Sine pi will become pi by 2. Sine pi by 2 is sine pi by 2 is going to be that is 1. So 3 plus 2, it is going to be 5. So when it is pi, the value is going to be here. So the graph is going to maximum like. So this is the turning point, it's going to come back here. So sine 2 pi is, when you put here x as 2 pi, so that will become pi over 4. So then it is going to become as 2. So this is going to come over here at this point. So graph is going to come over here, and then at 3 pi, this is the minimum value. So it is going to come like this up to here, like this. So this is the graph, right? Now the next one, we have stated the number of solution of the equation. We are not finding the solution, we are just telling the number of solution for this. So if you see, this is the y we are given here above, and we have now y equals to 5 minus 2x. We can find the points here for to plot this line on the graph. So x and y, when x is 0, y is going to be 5, and when y is 0, x is going to be 2.5, right? So now how will we plot this? We don't know. Along x-axis we have 0 and 2.5, which we don't have. We have here pi and 2 pi. So now, as you know that 2 pi is 3.14, right? 2 pi is going to be 6.28 multiplied by 2, and pi by 2 is going to be 1.57. So this is pi by 2, which is 1.57, and this is pi by 2, and this value is 3.14, right? So now our value of x is 0 and 5. 0 and 5, let me choose another color. So value of x is 0. When x is 0, y is 5. So we have 1 point here. Another one, x is 2.5. x 2.5 is somewhere here. 2.5 is going to be somewhere here in this side, and y is 0. Y is 0, let's say it's closer to this one. So we are going to plot, draw a line, just draw a line with your ruler like this. So this is the equation of a line of y equals to 2x. Now if you see at how many points this line intersect the graph, this cuts only at one point here. So how many solutions do we have? We will have here only one solution. So we are going to write down here one solution, right? That's number 7. Now let's do number 8. The function f and g are defined as follows. A and b are constant, fx is given, gx, and given that f7 is 5/2 and fg5 is 4, find the value of a and b. So now we are given f7 is 5/2, right? So we are going to substitute the value of x as 7 over here. So this will be fx 2a over 5/2, no sorry, x is 7 minus a is equal to 5/2. Now just simplify this one. This is going to be 2a over 7 minus a, 5/2 minus 1, that is 2a equals to, this is going to be 7 minus a as it is, 2 minus this is 3/2. Now let's cross multiply. When you cross multiply, it becomes 4a equals to 3 times this 21 minus 3a. So this is 7a equals to 21 and a is equal to 3. So we got the value of a as 3. Now what will be fx when a is 3? So this is 1 plus 2 times a is 3 now. And then we have x minus a, which is 3. So this is 1 plus 6 over x minus 3. Yeah, so sorry guys, 1 is separately, here it's not. Let me just rewrite these things, because 1 plus, that is 1 plus, not like as a whole. So we have fx here equals to 1 plus 2 times 3 over x minus 3. So this is 1 plus 6 over x minus 3. This is our fx now, right? So and we are looking for f5, because we are going to find out here g of f5. So we will do that over here, g of f5, which is 4. So f5, I'm going to substitute the value of x as 5 here. So f5 is 1 plus 6 over 5 minus 3. So 1 plus 6 over 2, which is 3. So f5 is 4. So our f5 is 4, right? So f5 is 4. We are going to substitute here. f5 is 4. So we have g4 as 4, right? So g4, substitute the value here, that is 4b minus 2 will be equals to 4. Then 4b is 6 and b is 6 over 4, that is 3/2. So that's the values of a and b. Okay, now part b. For the rest of the question, you should use the value of a which you found in part A. So here we have found the value of a as 3, right? So a is 3. Find the domain of f inverse s. Domain of f inverse x is going to be the range of fx, right? So for the range of fx, I will take fx here. Fx is now 1 plus 2 times 3. We already got that here, right? So we have for the fx here, it was where is it? Here, this one. Let me take this one. Fx is 1 plus 6 over x plus minus 3. So I'm taking this one here. So let's rewrite this one. We already got fx when a is 3, so fx is 1 plus 6 over x minus 3, right. Now we have all the values of a, the domain, a range of a we have here. We are given that x is greater than a, so x is greater than a and a is 3, so that means our x should be greater than 3, right. So for greater than 3 it can be 4. Let's try with the 4. f4 is 1 plus x, 4 minus 3 it's 1, that is 7. And then let's say f5 is going to be 1 plus 6 over 5 minus 3 2, that is 3, so it is going to be 4. And let's say f6 is 1 plus 6 over 6 minus 3 2, it is going to be 6, f6 6 minus 3 1 plus 1, it is going to be 2. So as you can see, when we increase the value of x here, the value of y is decreasing. So if we take let's say a bigger number, let's say I'm taking here 1000, so what will this become? This is 1 plus 6 over 1000 minus 3, that is approximately 1.00 something. So as you can see, if we plot a graph here, so x, we know that the value is at 3, right. So it is greater than 3, x should be greater than 3. So when x is 4, y is 7, let's say 7 is somewhere here, then when x is 5, then this value is going to go like this. Your graph is going like this, so it is not approaching this one because it cannot be 3. So as we approach this side, the graph is going decreasing, but it is greater than certain value which is 1. So that means the range is going to be, range x is going to be greater than x. So therefore domain of f inverse x is going to be greater than 1 always, right. Now find an expression for f inverse x. So for f inverse x, we have to take the value of fx. So we had fx as 1 plus 6 over x minus 3. I'm bringing 1 on other side, so now we can cross multiply. So this is going to be y minus 1 into x minus 3 equals to 6. What are we trying to do? Actually we are making x the subject. So now just expand the bracket, xy minus x minus 3y plus 3 equals to 6, right. So then we will have we can take out x common from here, right. So x common, we will have y minus 1. I'm shifting everything on other side, x 6 minus 6 plus 3y minus 3, right. So this is going to be 3y plus 3 and x is going to be over here y minus 1. So this is our value of f inverse x. Change this y to x, so this is 3x plus 3 over x minus 1. It was a simple question. So this is our f inverse x.